Today we'll be looking at a calculation that has to do with Gay Lussac's law of combining volumes. No, according to Gay Lussac's, we find out that gases they react in simple ratio with one another. That is, the reactants they react in simple ratio with one another and that of the products. So, and this relationship has to do with also the number of moles they have, which can, according to him, it can also be regarded as what the volume. So, we're going to look at it. Having this in our mind now, we're going to be looking at some calculations. I want you to pay undivided attention as we solve series of questions. I will make sure we solve more than enough. At least we're going to look at some questions that will help you understand how to deal with all these all the calculations. So here we will have a question. We have two questions here. Say that we have a chemical equation. This chemical equation showing us what happened between hydrogen and oxygen in this reaction. Say that in the reaction above, volume of hydrogen will be left over when 300 cm cube of oxygen and hydrogen exploded in a sealed tube. So we're going to what the examiner wants you to find out here is the volume of remaining hydrogen. We have actually there's something missing there. We're supposed to have 1000 cm cube 1000 cm cube of what um hydrogen when it combines. So now the equation is actually complete now. So what we do here, you notice that we have 300 cm cube of what oxygen combining with 3000 cm cube of hydrogen. Now the first thing we do here is to find out the actual volume of this that will react with the hydrogen, volume of hydrogen that will react with the volume, this 300 cm cube of what oxygen. That is what you need to find out from the chemical equation. From this chemical equation, according to Gay Lussac, from this chemical equation, which is balanced, so from this chemical equation we will find out that according to Gay Lussac, the volume relationship we have here is 2 cm cube and here is 1 cm cube and the other one is what 2 cm cube. So now having this in mind now, it means that from this balanced chemical equation, what it means is that 1 cm cube of oxygen will combine with 2 cm cube of what hydrogen. So if that be the case, what it simply means is that 1 cm cube of what oxygen will combine with 2 cm cube of hydrogen. 2 cm cube of hydrogen. Now, but what we have here is what 300 cm cube. Now 300 cm cube of the same oxygen will then be 2/1 times 300/1. That will give us 2 multiply this, we have was 600 cm cube of what of hydrogen that will combine. So we know that from this reaction now we want to find out the leftover of hydrogen. So if that's the case, we have 1000 cm cube of what hydrogen. So subtracting it from the one that reacted, because this one is gone, the 600 is gone as a result of the reaction between the 300 cm cube of the oxygen. So what we have remaining left over will be what 400 cm cube of what hydrogen. So let's quickly go down to the second one that we have here. The second one we have here says that calculate the volume of carbon 2 oxide required to react with 40 cm cube of oxygen. So now from the same chemical equation, no. So from this chemical equation, we notice that we are also looking for the same volume of carbon 4 that will react. Now we are looking for volume of carbon 4, but we know that from this balance equation, we have 1 cm cube of what? Oxygen will require 2 cm cube of what? Carbon 2. So 40 cm cube of oxygen will give us 2 over 1 times 40 over 1. That will give us 80 cm cube. 80 cm cube of what? Carbon 2 will combine with 40. Now, that's going back to Gay Lussac's law. He said that they do so in simple ratio with the volume. They combine in a volume that's simple ratio. Notice that the ratio of their volumes tends to be the same. So let's look at some other question again that will help us to understand. So the next question we have here, the question again said, calculate the volume of residual gases that will be produced when 100 cm cube of sulfur 4 oxide reacts with 20 cm cube of oxygen. We have the balanced chemical equation there. So let's quickly look at how we're going to do this. By looking at the balanced chemical equation, we have so from this chemical equation, we're looking for the residual gases. That is a kind of gases, that is meaning that the gas that is left over, residual gases that will remain, a gas that will remain after the chemical reaction. So we know that from this chemical equation, one of the gases that we'll have at the end of the reaction is this. For example, looking at this, 2 cm cube of carbon sulfur 4 will combine with 1 cm cube of oxygen to give us 2 cm cube of tetrasulfur 6 gas. So in this case, from this chemical equation, what will remain from here will be this 2 cm cube of tetrasulfur 6 gas. But then that is not what we're looking for. We are looking at, we are given some volumes. Volume of this oxygen is what? 20 cm cube, and volume of tetrasulfur sulfur 4 sulfur 4 oxide is what? 100. Now if you look at it, what the first thing we're going to do is to find out the volume that will react with this volume of this that will react with this 20 cm cube. Now looking at the chemical equation, then we know that 1 cm cube of oxygen will react with 2 cm cube of sulfur 4 gas. So then 20 cm cube of oxygen will then react with 2 over 1 times 20 over 1. That will give us 40 cm cube. 40 cm cube, that's what we have. So since we have 40 cm cube, what next? It means that what we are going to produce here is 40 cm cube. Okay, now what we are going to produce, because it's 2:2, it means that if 20 cm cube of this produce 40 cm cube of react with 40 cm cube of sulfur 4, then from this place we know that the volume given to us is 100. So what we mean, remaining gas will be 40. 100 minus 40, that will give us 60 cm cube of what? Sulfur 4 gas. That's the 60 cm cube, because this one is consumed by what? 20 cm cube of the oxygen to leave this one. Then this one is a remaining. The remaining is what? 60 cm cube. So now, what next are we going to find out here? Now the next thing we are going to know is the volume of this tetrasulfur 6 gas that is produced. That is what you need to find out. So if that being the case, looking at this, we find out that 2:2. meaning that if this one should give us 40 cm cube of this, it also means that it will produce what, 40 cm cube of what, tetrasulfur gas. So the residual gas in question, total residual gas that we have, total residual gas will then be 60 of the remaining sulfur 4 plus 40 of tetraoxosulfur 4 gas produced. So that 40 plus 40, what we have will be what, 100 cm cube of what, residual gas. So let's go down to the next one. The next question said we are going to be calculating another gases, so that the remaining gas in this question, it said 400 cm cube of air containing 21 cm cube of oxygen. If 60 cm cube of carbon 2 oxide bond completely with the air, calculate the volume of the gases remaining. So before we do that work, before we can do it, the first thing we're going to find out is the volume of oxygen that is in this 400 cm cube of air. We say that 21% of the air contains what? Oxygen. So what we do here is that volume of oxygen in the air will be 21 over 100 times 400 over 1. This will cancel out. This multiply 4 multiply 21, we have something that will look like this. That is 84 cm cube. That is the volume of oxygen that is in this very air in question. So now we have the volume of oxygen that's in that air. So the next thing we are going to do here, we look at the balanced chemical equation. From the balanced chemical equation, we will have something that will look like this. That is the balanced chemical equation. So from this reaction, we have 60 cm cube of carbon 4. That means we have 2 cm cube of carbon 2 will react with what? 1 cm cube of what? Oxygen. Now, how do I get this? You know, from their ratio, simple ratio 2 and 1. Coefficient of this, arithmetic ratio of this thing is 1, 2 is to 1. So that is why, according to Gay Lussac, we are to make it what? The volumes. The ratio of the combination can also be considered as what? Volume of the combination, combining volume. Now let's continue. Then 60 cm cube of carbon 2 will then be 1 over 2 times 60 over 1. That is what it will take. The volume of oxygen that will burn, this will cancel out. We have 30 cm cube. That means it will require 30 cm cube of what? Oxygen. Now, from this air we have, if it's 30 cm cube, the volume of remaining oxygen, because not all the oxygen reacted. So what we'll do now, volume of remaining oxygen is 84 minus 30. That will give us 4 here. Another one will give us 50 cm cube. That is one of the, this can be seen as one of the residual gases we are looking for. Perhaps we can have it. Let the gas has a place there. So now, what next we are going to do now? What we're going to do now is to, since we know the volume of this of the oxygen that's remaining, we need to find out the volume of carbon 4 that is produced. Now, if we have from this ratio, this is 2 cm cube, 2 cm cube, then it means that 60 cm cube of this will also produce what? 60 cm cube of carbon 4. So another gas will remain. Volume of carbon 4 produced. Volume of carbon 4 produced. Carbon 4 will be what? 60 cm cube. That is what we have, the volume of carbon 4 that we produce. Now, what next are we going to do? Then this is the remaining gases we have, which is our residual gases. Since it's our residual gases, what we do here is we add it up. Total residual gases will then be 54 plus 60. That will give us something that will look like this: 4, and then 1 cube. That is 114. Oh, what am I doing? 114 cube. That is what we have here. All right, thank you so much for being part of the class, and don't uh, don't forget to subscribe and like, and also comment. If you have any question you want to ask us, you can leave it as a comment. And you know one thing, when you subscribe like that, you give us more, uh, it encourages us to do more. All right, thank you so much. Thank you.